One of my students asked me a question the other day, Sir, why does 0 point energy exist? As in, पार्टिकल की एनर्जी क्वांटम मैकेनिक्स में कभी जीरो क्यों नहीं हो सकता, but instead it has a 0 point energy. So we can answer that question using Heisenberg's uncertainty principle. But first of all, what is 0 point energy? You see, in quantum mechanics, whenever a particle is in a potential, whenever a particle is in a bound state, it can never really have zero energy. The minimum energy that a particle can have is some non-zero value, which is also known as the ground state energy or sometimes 0 point energy. Now, ये जो quantum mechanics में होता है, it is very different from classical mechanics. Classical mechanics में particle rest पे हो सकता है. अगर particle rest पे है, तो in that system the particle has zero energy. But quantum mechanics में ऐसा नहीं होता. Quantum mechanics में particle can never have zero energy, but it will always have some non-zero finite energy, which is known as the ground state energy or 0 point energy. और इस चीज़ को explain करने के लिए we can use the Heisenberg's uncertainty principle. So now, what is the uncertainty principle? Well, the uncertainty principle says that whenever we are trying to measure two complementary physical quantities, such as position and momentum, then we can never really measure them with absolute accuracy simultaneously. मतलब अगर हम position और momentum एक ही particle का एक ही साथ measure करने की कोशिश करते हैं, तो the uncertainty involved in position and the uncertainty involved in momentum can never be reduced to an arbitrary value, but their products will always be greater than some kind of a number which is h cross upon 2. तो इसका मतलब ये है कि अगर हम पोजीशन की अनसर्टेनिटी को कम करते हैं तो मोमेंटम की अनसर्टेनिटी बढ़ जाएगी, और अगर हम मोमेंटम की अनसर्टेनिटी को कम करते हैं तो पोजीशन में अनसर्टेनिटी बढ़ जाएगी. सो दिस इज नोन एज द Heisenberg's uncertainty principle, and this gives us an explanation as to the existence of 0 point energy. First of all, why is it that Heisenberg's uncertainty principle exists? It exists because particles are not really particles. They are wave packets which are spread out in space. Particles जैसा हम classically imagine करते हैं कि एक particular point पे exist करता है, ऐसा नहीं होता. In quantum mechanics, particles are represented by wave packets that are spread out in position space as well as in momentum space. And the manner in which they are spread out in position space and in momentum space are inversely correlated to each other. Again, so keeping that aside, कैसे हम Heisenberg's uncertainty principle को use करके ये प्रूव कर सकते हैं कि कोई भी पार्टिकल जो किसी पोटेंशियल में है उसका मिनिमम एनर्जी कभी जीरो नहीं होगा, बल्कि एक ग्राउंड स्टेट एनर्जी होगा जिसको हम 0 पॉइंट एनर्जी कहते हैं. उसको दिखाने के लिए लेट मी टेक द मोस्ट सिंपलेस्ट ऑफ एग्जांपल्स, व्हिच इज द हार्मोनिक ऑसिलेटर पोटेंशियल. 1D हार्मोनिक ऑसिलेटर पोटेंशियल क्यों ले रहे हैं? बिकॉज whenever there is some kind of a potential in which there is a minima and a particle is stuck in that potential well, so for sufficiently small displacements we can always approximate that potential well by a harmonic oscillator. In physics, harmonic oscillator is a very popular, very famous, and it is seen in various different kinds of physical systems. So this is one of the most common examples that we can take. So I am going to demonstrate to you that for a harmonic oscillator potential well, applying the Heisenberg's uncertainty principle, we can derive the 0 point energy. We can show that the minimum energy possible is never really zero. तो उसके लिए मेरे पास क्या है? I have the form of the potential. The potential of a harmonic oscillator well is given by this. So in that system, the total amount of energy is given by, this is not the correct expression. The total amount of energy is given by P square upon 2m plus half m omega square x square. Now, I am interested in finding what is the minimum possible energy, right? So the minimum possible energy depends upon the momentum as well as the position, right? Now in a classical system, position can always be zero, not a problem. If you have a spring mass system, if the position is at zero, if the system is at equilibrium, then there is no oscillations happening, so energy of the system is zero. But in quantum system, because of the uncertainty principle, we can never really pinpoint the position of a particle to be zero. There is always some sort of an uncertainty that is associated with the minimum measurement of position. So let's suppose कि मैं अगर position को measure करता हूँ, then the minimum possible value of the position can never really be less than x. And the minimum possible value of the momentum along the x-axis can never really be less than del p. What is del x? Del x is the uncertainty in the measurement of position. What is del p? Del p is the uncertainty in the measurement of momentum along the x-axis. And how is del x and del p related to each other? Well, del p is equal to, क्योंकि हम मिनिमम की बात कर रहे हैं तो इसलिए मैं इक्वालिटी साइन यूज कर रहा हूँ, is equal to h cross upon 2 del x. So what is the minimum possible momentum of the system? उसको हम मैं p से denote करूँगा, just for the sake of simplicity in my writing the expressions, अभी for the sake of this calculation. And this is therefore equal to h cross upon 2x. यहाँ पे ये चीज़ समझिए कि p is not necessarily equal to del p, but it is only equal to del p when we are considering this situation where the momentum is minimum, and similarly the position where the uncertainty in the position is minimum, just so that मेरे expressions जो है थोड़े simple आ जाए. So for the minimum case scenario, I end up getting p square upon 2m. तो p square क्या है यहाँ पे? It is 1 upon 2m, and then here I have h cross upon twice x. Again I have half m omega square x square. यहाँ पे there is a square. So this becomes, this is equal to h cross square upon 8m x square plus half m omega square x square. So इसका मतलब क्या है? इसका मतलब ये है that if a particle is at a particular position x, then the minimum possible value of energy is given by this particular expression. Now, overall, if I want to minimize this further, if I want to say that, okay, out of all possible scenarios in which the particle exists, what is the minimum value of this energy? If we can improve the accuracy of measurement to as much as it is possible, अगर हमने ऐसा एक एक्सपेरिमेंट डिवाइस किया जहाँ पे मोमेंटम को जितना एक्यूरेटली मेजर कर सकते हैं उतना कर पाए, और पोजीशन को जितना एक्यूरेटली मेजर कर सके उतना कर पाए, और सिस्टम को हमने इस तरह से डिवाइस किया दैट द अनसर्टेनिटीज आर मिनिमम, इन दैट सिचुएशन what is the actual value of this minimum energy? उसके लिए what I am going to do is I am going to try to minimize this quantity. So let's suppose that we try to minimize this with respect to x. So if I try to minimize E minimum here, okay, so E minimum, as you can see, is dependent right now upon x. So it is a function of x. So I want to find that value of x for which this E minimum is lowest out of all possible scenarios. How to do that? Well, I differentiate with respect to x and then I make it equal to 0. So to minimize this, I'm going to do d E minimum upon dx, and then I'm going to make it equal to 0, and from there I'll get the value of x for which this is this minimum value of energy is the lowest out of all possible scenarios. So this is equal to d upon dx, and in the bracket we have h cross square upon 8 mx square plus half m omega square x square. This is equal to 0. इसको solve करते हैं. Let's solve this. Here I should get h cross square upon 8m, and this is minus 2, and I'll have 1 upon x cube plus here I should get half m omega square. Twice of x is equal to 0. So this expression should simply become half, and half here gets cancelled, and I end up getting m omega square x is equal to, here the 2 and the 8 will become 1 by 4, and I end up getting h cross square upon 4m x cube. So यहाँ से हमें क्या मिलता है? यहाँ से हमें मिलता है that 4 m square omega square x to the power 4 is equal to h cut square, or I can simply say that h to the power 4 is equal to h cut square upon 4m omega square. Thus, for the value of x for which out of all possible situations we end up getting the minimum energy for a particle which is stuck in a potential well is given by m square होगा root over h cut upon 2m omega. ठीक है? So this is an expression that we have obtained. Now let us substitute this expression back into our expression for the minimum value of energy. Okay, so here we have an expression for the minimum value of energy that is dependent on the x coordinate, and now we have sort of found out the possible value of x coordinate for which the system out of all possible configurations will exhibit the lowest amount of energy. So let us substitute point number 2 in point number 1. इनको सब्स्टिट्यूट करने के बाद हमें क्या मिलेगा? सो ई मिनिमम इज इक्वल टू, सो यहां पे क्या है, h क्रॉस स्क्वायर अपॉन 8mx स्क्वायर, h क्रॉस स्क्वायर अपॉन 8mx स्क्वायर प्लस हाफ m ओमेगा स्क्वायर x स्क्वायर, यही है ना? So let's substitute point number 2 here. So if I do that, h cross square upon 8m x square should give us h cross upon 2m omega plus half m omega square. X square should give us h cross upon 2m omega. So let us simplify this expression and see what we get. We'll get a very interesting result. So यहाँ पे जो है आपका h cross, ये square cancel हो जाएगा, m gets cancelled. यहाँ पे you'll have omega, this will get cancelled, m will get cancelled, and यहाँ पे the 2 will cancel out 8 and leave a 4. So this is equal to 1 by 4 h cut omega plus यहाँ पे 1 by 4 h cut omega, which is nothing but half h cut omega. Do you recognize this expression? This expression is nothing but the ground state energy of a harmonic oscillator. So this minimum energy that we have obtained by the Heisenberg's uncertainty principle for a particle that is stuck in some kind of a harmonic potential is exactly equal to the minimum energy that is calculated by solving the Schrodinger's equation for a harmonic oscillator potential well. So harmonic oscillator potential well के लिए आपको मालूम होगा that the energy expressions are given by En is equal to n plus half h cut omega, where the lowest possible value of n is given by 0. So this is equal to 0 plus half. So this is half h cut omega. So this, as you see, is exactly the same result here. So that means that using Heisenberg's uncertainty principle, we can calculate the minimum amount of energy that any particle in a given potential well can have. And since we can never really with 100% accuracy measure the momentum of a particle as long as it is confined in a region, इसका मतलब ये है कि उसका कोई मिनिमम मोमेंटम तो ज़रूर होगा, और अगर मिनिमम मोमेंटम है तो उसका मिनिमम एनर्जी भी ज़रूर होगा. दिस इज़ द रीजनिंग बिहाइंड ज़ीरो पॉइंट एनर्जी. अगर कोई पार्टिकल किसी भी क्वांटम सिस्टम में बाउंड है तो उसका मिनिमम एनर्जी कभी ज़ीरो नहीं होगा, बल्कि एक नॉन ज़ीरो वैल्यू होगा, जिसको बोलते हैं ज़ीरो पॉइंट एनर्जी या फिर ground state energy in this case. That is all for today. Thank you very much.